Hello, welcome to this video by the Eastern Alliance for Greenhouse Action, or EAGA as it's otherwise known. EAGA is one of the 10 greenhouse alliances in Victoria. The greenhouse alliances are formal partnerships of local governments driving climate change action across Victoria's 79 municipalities. My name's Adam Sholikoff, Manager of Resilient Assets at EAGA between August 2020 and May 2021. The Resilient Emergency Relief Centre project ran during the financial year 2021. Its objectives were to assess selected emergency relief centres, or ERCs, to identify opportunities to improve their resilience to climate change. It was to improve understanding on ways to assess climate vulnerability of buildings and assets and how to improve this. It was to build capacity of councils to address climate change risks and to share learnings and findings with others. The approach taken included firstly workshops to introduce the project to its stakeholders at the different councils, engage the stakeholders to participate in the project with a good understanding of it, and then select buildings for assessment. Completion of building vulnerability assessments, or BVAs, with council staff was the key next step, and that involved identifying the exposure of components of the buildings to climate change and the sensitivity of components to climate change. Together, these pieces of information form the potential impact rating of climate change on the building, and that is combined with the importance of each building component for the building's continued use to determine the vulnerability rating of each building component and the building components overall, the building overall. The outputs of the project. Firstly, we've reviewed the building vulnerability checklist to determine, is it appropriate, is it effective, would we change it in the future, and produced a set of specifications that can be used by councils to guide their new buildings design and construction and significant renewals of existing buildings. In addition, building vulnerability assessment reports are produced for each of the 8 member councils participating in the project. So the outputs lead to some strategic actions being recommended to councils and some recommended adaptation measures that can be applied to each of the buildings assessed to improve their building climate resilience and manage their vulnerabilities. The key building vulnerability findings based on their functional requirements. What are the top 5? So, power and supply from the electricity grid to the building was a key vulnerability. When there is a failure or a blackout, the building has the risk of having no electricity. As a result, safety could be compromised. No lighting, safety lighting, air conditioning, heating, IT services and communications can be lost, and continuity of the building services can be lost or restricted. So an adaptation measure for that is to investigate options for backup supply power and install or connect the best option. Thermal comfort came out as a high vulnerability in all the buildings. That ranged from the cooling equipment being threatened by higher temperatures, extreme wind impact on the cooling equipment, heating equipment, roofs, external walls, windows and doors being subject to high outdoor temperatures, which can be transferred into the building via conduction and air infiltration. This led to an inability to achieve safe indoor temperatures potentially, and threatens the function and service continuity of the building. Adaptation measures vary widely for thermal comfort. Primarily to improve the thermal efficiency of the building envelope would be a key action, and to manage the heat that cooling systems are exposed to, another opportunity. The structural performance of buildings was identified as a vulnerability based on climate changes that are current and expected in the future. That varied widely from roofs, external walls, windows and doors being subject to higher temperatures, expansion of materials leading to structural damage, roofs, walls, windows and doors being exposed to extreme winds. Again, structural failure, safety, function and service continuity are threatened. Foundations and ground slabs vulnerable to heavier rainfall and expansion of soils. Structure threatened again. Ground slabs and foundations subject to lower average rainfall can lead to soil contraction and heave of buildings, and extreme winds lead to vulnerabilities in terms of foundations and slabs and structural failure as well. All possible implications of climate change. So to manage those, building structures need to be reviewed, their integrity by a specialist structural engineer is the recommendation. Next key functional requirement was indoor air quality threatened by dust or smoke movement into the building. That could lead to poor or unhealthy indoor air quality, can make floors slippery or unsafe, particularly in sporting venues, may require cleaning and lead to lack of service continuity if there's a significant indoor air quality issue. So managing the threat either at the source or via a pathway into the building is a recommended adaptation measure there. Weatherproofing, so that's about water ingress into the building. So at the roof, drainage and stormwater systems, all potential threats of heavy rainfall entering the building, also doors, windows and leaks in the walls. So managing or identifying those vulnerabilities in each building particularly, and then managing specific risks. Other options recommended there. Building components, which ones are the most vulnerable to climate change? So we were able to determine that power supply from the grid with no backup supply is the most frequent risk, alongside windows and doors transferring extreme temperatures with a high rate of conduction. Extreme rain penetrating windows and doors with water ingress being a risk, and walls as well, a risk from extreme rain. Windows and doors, walls, yep. Extreme temperatures and infiltration of drafts through windows and doors was a key risk and vulnerability. Cooling equipment was also highly exposed to hotter temperatures, and as a result suffer more wear and tear with higher operating costs and higher greenhouse emissions. So that's a vulnerability. Windows and doors at risk from high winds and debris derived from the high wind, as in limbs and trees dropping on a building, damaging the cooling or heating equipment. And roof structures at risk from extreme rain, potential leaking and sagging of the structure. So there's a range of key vulnerabilities, but they are the highest vulnerabilities identified in this study. Which types of buildings were the least and most vulnerable to climate change? So libraries appeared the least vulnerable, as well as theatres, performing arts centres and town halls, followed primarily by sporting pavilions. The types of buildings that appeared the most vulnerable were leisure centres and community centres, which had a much higher number of high and very high vulnerability components. What does this suggest? Some buildings look to be more suited to be used as ERCs in regard to climate resilience or vulnerability. They include libraries, theatres, town halls, and pavilions. They all appeared to be less vulnerable to climate change impacts, whereas leisure centres and community centres have many more climate vulnerabilities from this study. What is the indicative cost of recommended adaptation measures per square metre at the different building types? So town halls appeared to be the cheapest to improve per square metre, followed by theatres, performing arts centres, leisure centres and libraries. Community centres and pavilions appeared to be more expensive relatively compared to the earlier building types. Now, these are just indicative relative costings based on a sample of 23 buildings and the recommended adaptations and their indicative costs for those works or investigations. It does need further research, but this is our first example of relative costs for proposed adaptation measures at the different types of buildings. So this basically suggests some buildings may be less expensive per metre squared to improve in regard to climate vulnerability relative to others. Opportunities to progress towards climate resilient buildings and assets. What are those opportunities? So staff engagement with the building vulnerability assessment process and climate resilience is critical, and a revision to the existing asset management plans, policies and procedures. Internal governance needs or can improve to have responsibility for implementation of either an environmentally sustainable design policy and/or climate resilience, climate vulnerability monitoring and improvement. Implementation of recommendations from the building vulnerability reports would be critical to improving climate resilience of buildings and assets. So looking at the actions recommended at each building, determining costs and benefits for each and identifying which are the highest priorities for each council to deliver at each site. Budgeting for environmentally sustainable design to build really climate resilient buildings would be the Rolls-Royce ideal outcome. But in existing buildings, it's about budgeting in the building renewal process to improve their climate resilience by targeting their current climate vulnerabilities and improving the climate resilience, managing these risks. In-house capability and capacity. This could be improved to deliver both environmentally sustainable design in new buildings and/or more climate resilient buildings by reviewing and improving the existing buildings. And this requires support for staff in the asset, facilities, sustainability teams. So they've got the awareness, the skills and capacity and resources to improve the buildings or build really highly efficient, environmentally sustainable buildings. Finally, reporting on ESD or environmentally sustainable design and climate resilience. This could be linked to strategic governance and objectives at the council level and flow down to provide key performance indicators for directors, general managers, managers, coordinators and staff regarding achievement of ESD and climate resilience in buildings. Project learnings. What were the key learnings of the project? Simplifying the building vulnerability framework or process will help asset management, facilities management staff and sustainability staff to monitor their buildings' vulnerabilities in regard to climate change So creation of a shorter checklist has occurred, and that would be great to trial in some buildings of councils to determine the vulnerabilities at each building and the opportunities for improvement. Next, to change asset management processes and engage staff so that building climate resilience is a key objective that we're trying to achieve. And then the strategic changes and the operational changes to achieve that. Assessing buildings for climate vulnerability, it definitely helps planning of asset management. It identifies existing vulnerabilities and allows a determination of potential upgrades and adaptation measures to buildings to improve their climate resilience. There are a lot of benefits of improving the energy efficiency, the climate resilience of buildings, improving indoor temperature, cost of operation, reduced greenhouse gas emissions, improved productivity of staff, improved retention of staff, amongst the co-benefits of improving the energy efficiency of buildings. Emergency relief centres were not designed or constructed to be used as ERCs. Many buildings in council were designed in the 40s, the 50s, the 60s, the 70s of the 1900s, and therefore the building code, the National Construction Code, didn't require buildings that could be as efficient as we know we can construct today. So the buildings weren't designed to be ERCs particularly. Council buildings weren't designed or constructed for climate change. Our climate has changed. We have a 1 degree warmer climate in Melbourne. It may increase to up to 3 degrees further warmth in Melbourne, in Victoria. So buildings ideally need to be built for purpose and the context that they'll operate in. Council buildings also, it was clear that they are vulnerable to climate change. It does provide an opportunity to improve these buildings, and council buildings are likely to be far better once they've been assessed and improved with some targeted climate vulnerability management works. Another project learning is council's awareness of climate vulnerabilities and the cost of business as usual, do what we're doing now, could improve. We can make savings, improve productivity, and increase the safety of council buildings by improving their climate resilience. Thank you. Okay, that's a snapshot of the EAGA Resilient Emergency Relief Centre project. Thanks.